Have you ever thought of how much energy your building consumes or will consume in the future? Can you predict or estimate this consumption in a short period of time? The answer is yes. To do a quick and accurate estimate of building energy consumption, we can use energy modeling. Energy modeling is a great tool to estimate energy use in new and existing buildings. Cyclone uses sophisticated software simulating building virtual environment to predict energy patterns on an annual basis and to estimate multiple realistic scenarios. Energy models are used to assess all categories of energy consumption in buildings. Energy modeling is a vital tool when planning high-performance buildings. It's even more important when designing net-zero energy buildings. If you want your building to be energy efficient and desirable for your tenants or buyers, I encourage you to use energy modeling in new construction projects as early as possible. Engaging energy modeler in early design process will eventually help you reduce building operation cost, enhance occupant well-being, and create productive workspace and happier world around us. Think about the kind of environment we will leave behind us for future generations to live in, and how it's going to affect their well-being. Energy modeling is a helpful decision-making tool for architects that can influence how the building will look and perform. It will allow the architect to scientifically decide on building shape, site orientation, the amount of building glazing, type of envelope material specific to a particular climate, all of which will affect building construction and operation cost. Designing efficient envelope is a critical component of building performance. Modeling multiple options of exterior wall, roof, and glazing thermal properties along with moisture analysis allows for well-informed selection of the envelope optimal design. Lighting engineers could benefit from energy modeling by testing and improving their designs. Simply select desired lighting fixture from a manufacturer's catalog and evaluate their lighting intensity and energy effect. Study control strategies and daylight and occupancy sensors locations. Decide on the best lighting options and produce the most efficient design. Daylight analysis is a big part of design process, and it can be done only by energy modeling. Daylighting helps reduce building energy use and improves occupants' comfort. To integrate daylight, we need to account for surrounding environment, external shading devices, and glazing properties, at the same time controlling sun, glare effect, and artificial lighting. Energy modeling allows mechanical engineers to test different HVAC systems, to size equipment capacities, to select optimal system efficiency, to estimate system cost, investigate performance of a conventional chiller boiler system or state-of-the-art ground source water VRF heat pump system. Renewable energy potential for your project can also be assessed with energy models. Use them to find optimal inclination angle and area of PV panels, estimate wind turbine feasibility for a particular site, or to minimize HVAC use by incorporating natural ventilation strategies and get the results in a matter of hours. When all the design decisions are made and all specifications are put together, it's time to get a building permit from a city. There are two ways to get a building permit to comply with energy code requirements: the prescriptive or trade-off pass using ComCheck tool, and the performance pass using the energy model. The prescriptive or trade-off pass means all building components must meet the code, including building envelope, internal and external lighting power densities, and HVAC equipment efficiencies. If any of these components happen to be below the minimum allowed by the energy code, your project will fail to get the permit. On the other hand, the performance pass lets you do trade-off options between any components of the building. For example, you want to build a building with 70% window-to-wall area ratio, but code allows only 40%. The prescriptive method would not be an option in this case. Instead, use the performance pass using energy modeling that can show that your building performs better than the minimum allowed by code. And it would happen because your specified lighting or mechanical system might perform better than the code, which offset the negative effect of the increased glazing area. So overall, your building might outperform the minimum code energy requirements in terms of annual energy consumption and cost. Great marketing opportunity for any commercial or multifamily building are green building certifications, such as LEED or Living Building Challenge. People prefer to work and to live in sustainable buildings, which offer comfort and have environmentally friendly vibe. To obtain any green certification, the design team is required to have an energy model to provide predicted building energy performance and to show annual energy cost savings over the code minimum. Energy modeling can yield credits in several lead categories, including energy and atmosphere, indoor air quality, and water use reduction. For existing buildings, we can use energy modeling to calculate savings for optimized building controls or for retrofitted HVAC equipment. Models can estimate not only cost savings due to reduced energy use, but provide a full life cycle cost analysis, identifying the best solution for your building and the amount of money you want to spend on it at any given time period. Energy models of your existing buildings can be calibrated to actual energy consumption. Meter the energy use, collect this measured data, feed them into the energy model, and calibrate it to match the actual bills. Calibration will help to tune up the building or find errors in operation due to a human factor or system controls faults. There are many government programs to incentivize energy use reduction in existing buildings. Energy modeling can be used to get your hands on this free money to spend on your building retrofits. We can study your building, identify the most desirable and economically feasible options, and help you fund building improvements of your choice. Here at Cyclone, we work on about 50 projects a year, ranging from small car washes to 1 million square foot distribution centers, manufacturing, refrigeration facilities, high-rise multifamily buildings and student dormitories, offices and mixed-use buildings, schools and natatoriums. You name it, we can model it. And remember, it's your buildings, only better.